So next I'm going to show you how to use dynamic locking in NTAg 212. So I'm going to place a new NTAg 212 card and connect the box. Click on the select and finally click on the go. And as you can see here, this is a very new card and all the data blocks or the pages are set to zeros. Click on the locks and you can see that you've got a section called the dynamic page locking. What you see here is a representation of the 3-byte dynamic lock which is present in page number 36, the byte 0, 1 and 2, and the documentation says the value of byte 3 is always BD. So this section shows how you can lock the pages. For example, the top bit, when this is clicked or ticked, this is going to lock the page 30 and 31. So as the documentation says, each bit in the dynamic locking data locks 2 pages. So I'm not going to lock using this card because in UK getting NTAg 212 is not that easy. So what I'm going to do is I already have an NTAg 212 which has been locked a couple of pages. I'm going to try on them. So first you stop it and change with my existing tag and click on select and click on go. So when you work with NTAg 212, is worth noticing various sections here. This is the data you get when you call this get version command. This is the 32-byte ECC signature and these are the locks. So here I already locked page 30, 31 and 28 and 29. If you go there, you can see that from 28 to 31 is locked. I'm going to put some data in page number 18 to 19, say here, and I'm going to lock it. Or you can also put data in 4 pages. So just go here and this is page 18. So I'm going to put, say, just a HTTP. I'm going to create a small URL, HTTP, right? And in the next page I'm going to put :2/ I can put say W and right. On the next page I can put we had one more two W's dot, say for example test T, right? So you can keep this in ASCII mode so we know what we are writing. So I'm trying to write a URL, HTTP /www dot, say test. So click on page 21, go to text, so st dot, right, and finally on next page 22 I'm going to write so com and put a /. So I've just written a valid URL, http www.test.com, and I want to lock from page number 18 to 22. So we have to first find out which locking bits cover all these pages. So as you can see here, 18 is this one, 18, this lock bit for locking 18 and 19, and 20, 21 is this bit, and 22. So because 23 is not used, you can't just lock just one page. So once you set all the bits, click on the right and you get the dynamic updated message. So to try if the lock is really worked, you can stop it and place it back again and go here and say go, and if you scroll down you can see that you have the data. You have the data here. Okay, so that is how you work on dynamic locking. So these locks that starts with BL, as the documentation says, these are called the block locking. Assume that you do not want the user to make any more changes for these two locks, so you want this to be always unlocked. So to do that, you have to first identify which BL covers these pages. Assume that I've decided to prevent user locking from page number 34 and 33. So to do that, as you can see here, 32 to 35. So if I lock this, so user cannot, if basically when you lock this, so these two bits also get read only, you can't modify. So right, so as you can see here, the page 34, 35, 32, 33, they are not locked. However, we cannot lock it, or a user cannot lock it. So that's the meaning of this block locking. So you have to keep trying this block locking to understand how exactly they work. The other bits are NTAg 212 has got password and pack, everything very similar to NTAg 210. Next, I'm going to show you how to use NTAg 213, 215 and 216. The tags 213 and 216 are easily available from internet. However, it's very difficult to get NTAg 215. So the reason all these three different tags are explained in the same documentation is they are all very similar. Just like NTAg 210 and 212 are similar, these three tags are very similar in structure, functionality, and the only difference is each tags are of different sizes. So if you go to page number 6, and here you find some information about the capacity and the user memory, etc. Say for example, NTAg 213, as the documentation says, has got 180 bytes organized in 45 pages, and out of which 144 bytes are for read and write. This is the user memory, and all other bits are reserved, just like in any other NTAGs. Similarly, NTAG 215, it has got 540 bytes in total, out of which 504 bytes are for user read and write. And the next is the NTAG 216. This is the highest memory, which has got 924 bytes, out of which we have 808 bytes in user memory. So it's just the different memory sizes, these tags are pretty different. Then you can go to page number 11. This is very interesting for us, the memory organization. So this is very similar to NTAG 210 and 212. Say we had all these NTAGs have got the UID stored in the first three pages. You got the static locks, which are stored here, the 2 bytes in page 3, and we have the OTP, which is in page 3, and we have got all the user memory here. Say followed by the dynamic locking, which we just saw in NTAG 212, and the configuration byte CFG0, and the second configuration byte we have the 32-bit password, and finally the PACK, the password acknowledged byte. So this is very similar to NTAG 212. So I'm not going to discuss all the similarities in this video. So if you go to NTAG 215, again the difference here is the amount of memory available here, which is shown here. Otherwise everything is similar to NTAG 213. And the next is the NTAG 216, and this has got the highest memory. It has got altogether, it has got 230 pages. And finally it has got, like all NTAGs, it has got a UID which is 7-byte UID, and it has got a static clock bytes which is very similar to right from the ultralight and NTAG 202 onwards. And the dynamic clock bits are pretty interesting here because of different memory sizes. Each bit, the dynamic clock bits, controls from 5 to 10 or 15 pages. So this is the structure of the dynamic log bytes of NTAG 212. So as you can see here, there are 3 bytes just like NTAG 212. However, each bit controls two pages. I think this is very similar to the NTAG 212. And we also know what is this block locking. Say for example BL 36 to 39 are used to lock data from here, these 2 bits. And if you see the dynamic log bytes for NTAG, so for NTAG 215, as you can see here, each bit controls, in this case, here it's only 1 page, whereas here it's something like a 10 pages. So one dynamic log bit can log 10 pages. Say for example here from page number 96 to 111. And one more example is this bit controls from page number 16 to 31, and the corresponding block locking bits are here. So these block locking bits can be used to log 112 to 129, say somewhere from here, these two the last 2 bits. And the dynamic log bytes for NTAG 216, as you can see here, each bit can log somewhere from 10 to 15 pages. Say for example in this case it logs from page 32 to 47, more or less 15 pages. Likewise here as well. And also these are the corresponding block locking bits. So this can lock the bit 144 to 175, which is somewhere these 2 bits, so 144 to 175. So by setting this bit, you're basically locking these 2 bits as well. So next I'm going to show you NTAG 213 and 216. So NTAG 213, I'm going to connect my box and click on a select and go to NTAG 213, click on a go. This card is already been used. So as you can see here, this has got 45 pages altogether. And if you click on the version and signature, so here it is the storage bit that is different from NTAG 212 and 215. So here in this case it's 0F, and like the NTAG 212, this also has got its own ECC, the 30-bit ECC over here. And click on the locks. Again, it's very similar to in operation, which has got the static locks here and the dynamic locks below that. As you can see here, this is very similar to NTAG 212 because each bit controls 2 pages. So I'm going to stop and try NTAG 216. So click on a go, and this will take some time because this has got around 880 pages, something like that. So as you can see here, the green light is blinking for a long time. So if you go to the last page, so we have got around 230 pages altogether. And as you can see here, the dynamic log bits, okay, are also shown here. So each bit controls something like 15 pages. And if you go back to the version signature, so the one which differentiates between the other tags are the storage size. In this case it is 13, and it has got its own EC signature.